All right, guys, I actually want to add to our table of contents a little bit. I know we already have through 115, and that's what I'm going to work on today, but I do want to make a little note in here that like 113 and 114, so like right in between there is some like area with trig. So area plus trig. And specifically what I want to talk at the beginning of this video about is another area formula for a triangle. And so that's going to be on that page. So area of a triangle, which I know we've already talked about area of a triangle a bunch of times. Like area of a triangle is half base times height. We also did, like on page 111 right here, area of a regular triangle, aka an equilateral one, where you can do half apothem times perimeter. But on 114 right here, which I know I took some notes with you guys on the last time, I also want to talk about another area formula for a triangle. So under here, another area formula for a triangle. And this one is super nice because you don't need to have a 90, you don't need to have a height. So we're going to make this little note: without a proper height or a 90-degree angle, you can still find the area of a triangle like that, which is pretty cool. Like I normally would have you guys do this investigation, but just because of time and I want to get through as much as we can get through, I'm just going to give you the formula, which is kind of a bummer, but it is super helpful. So the area formula is half side 1 times side 2 times the sine of the angle in between. So we maybe need a little picture to go along with this, and then I'm going to do a couple examples. So if I had just a regular old triangle like this, if I'm trying to use this area formula here, I could maybe say that side 1 is like this, and then side 2 is like this. And then when I'm talking about the angle in between, it has to be the angle in between right here. So when you are looking at the area formula for this type of triangle, you need to have like a side angle side thing going on. Again, where these are your two sides and the angle is in between. So let's try 2 quick examples like that. So if I had a triangle like this, where one side here is 5 inches and this side here is 6 inches, and then the angle in between is 140 degrees. Because I have a side angle side thing going on, I can use this area formula, and you just plug everything in. So like half times 5 times 6 times sine of the angle in between. And this is also kind of why I saved this one for this page, because it uses trig again. And so right here I have 30, and I can take half of that for 15. So then really all I'm doing on my calculator is 15 times the sine of 140 degrees. Boop. So calculator time. We're going to do 140 sine and then times 15. For an area of approximately 9.64 inches squared. Real teeny tiny triangle, which makes sense because it's 6 and 5. So, and maybe one more like that, guys. So just to try it out, let's say we had a triangle that was like almost a 90. We'll say 4 inches here, 7 inches there, and then 96 degrees. And the reason I always like to do one that's almost 90 is because then you can kind of see how it all relates, hopefully. Make the numbers make sense. Because this is not a 90, I can use this formula here, half side 1 times side 2 times the angle, the sine of the angle in between. So I would do, because I have a side angle side, half times 4 times 7 times sine of 96 degrees. And so this is 28, and half of that is 14. So we're going to have 14 times the sine of 96 degrees. Calculator time. So we're going to do 96 sine, and then times 14. And we get almost 14. Like, this is approximately 13.92 inches squared. And I like to point this out because if it was 90, I would just do half base times height, which would be half 4 times 7, which is just 14. And this is almost 14. And also, that kind of also tells me that the sine of 90 is really 1, which is cool. Okay, fun facts. So guys, you could probably stop the video here if you felt okay with our area of regular polygons that we did the last time. Because what I want to do now is just a whole bunch more examples of those. Normally I would do it in a separate video, but I'm just going to continue in this one. And if you feel good about it and you don't need to watch any more examples, you can stop now. Otherwise, I'm going to go to 115 and do some more area of regular polygon stuff. So if we remember, the apothem is the segment that connects the center to the side at a 90. It's kind of like a height. It doesn't have to go straight down. It can go any which way it wants to go. I usually like to draw it straight down, but center to side. I need to find that apothem, and I need to know the side if I want to do my half apothem times perimeter. And so we're hoping that they give me one of those two things. So in this case here, they did give me this side, which is so nice because that will help me to find perimeter. So we're going to do 10 times 5 because this is a pentagon. And then I'm going to need to think about my little baby right triangle right here. And on the little baby right triangle, since I know that the full side is 10, half of it is 5. And then we're always trying to find that central angle to know if I can use a special right triangle or if I have to use trig. And so we do 360 divided by 5 because there are 5 sides, which is 72. And then I split that in half again for 36, which means we are not doing a special right triangle. We are doing trig. So because I know that my central angle is 36, and I want this apothem right here, which is adjacent, and I have the side that is opposite, I'm going to use tangent. And guys, just generally speaking, if you know either your side or your apothem and you're just finding one or the other, you're always going to use tangent. If you have to find both, like the side and the apothem because they gave you the radius, you're always going to have to use sine and cosine. So if you have to find both, you have to use both trig functions. If you only have to find one, then you only need tangent. So to find my apothem, we're going to take tangent of our angle equals the opposite side, which is 5, over the adjacent side, which I do not know. And then I'm going to want to do a swappy swap because my unknown is under. And so we'll have A equals 5 divided by the tangent of 36. And it's calculator time. So we'll do 5 divided by 36 tangent equals my apothem, which is 6.88. I'm going to leave that on my calculator because I think I might be able to use it to get a better. Oh yeah, because like if I look back at my formula now, over here I have 50 and I can take half of that for 25. So really I'm just doing 25 times the apothem, which I have right here. So now I can just hit times 25, and then I feel better because I rounded less. And so the area is approximately 172.05 units squared. Let's try some more. Looking at this top one here, I have a side, and I'm going to want that apothem to use half apothem times perimeter. But since I do know the side, I can find perimeter right now by doing 10 times 3, because there are 3 sides. So since I want to find the apothem, I'm going to have to first find that central angle by doing 360 divided by the number of sides, which is going to be 120, and then split that in half for 60. So my central angle here is 60, which means that it's a special right triangle, so I don't have to use TRIG. So now, since I want to find my apothem, which is this side here, half the side is 5, and that is opposite your 60, which is where the root 3 is supposed to be, which means I need to divide it out, but really what ends up happening is I divide by 3 and put a root 3 to find this shorter side, which is my apothem. And so now I can go fill it in, and we'll have 5 over 3 root 3 times 30. And that's kind of nice because now I can start simplifying stuff. Like I can see that the 3 goes into 30 10 times. And then the 2 does not go into 5, but it does go into 10 5 times. And so I don't have any denominators left. All I have left is the numerator, which is 5, 5, and root 3. So 25 root 3 is the precise area. I love it when I have a special right triangle because I can get the exact area. I don't have to get approximate area. Let's try another. Let's go right below that one. So right below this one, I have a hexagon, and we're going to do half apothem times perimeter, which in this case, I know the apothem is 2 root 3. So I'm going to have to go find the side length so that I can do side times number of sides, which is 6, to find the area. To find that side length, I'm going to want to find that central angle first. So we do 360 divided by 6, because there are 6 sides, and then split that in half again for 30. So I have another 30, 60, 90 triangle. It's just in like the flipped up direction. So on my 30, 60, 90, I know the side across from 60 is 2 root 3, which is where the root 3 is supposed to be. So that shorter side is just going to be 2. I just take the root 3 off, which makes it super easy to find my side because now I just take the 2 and I double it because I always have to double a side. And so my side length is 4. So you can just go plug in the 4. And when I'm multiplying here, guys, I should have mentioned this maybe before, but I always ignore the root 3. Like I just ignore it and chop it on at the end or like tack it on at the end. So you can take half of whatever. I'm just going to take half of the 2 because they'll just go away. And then I have 4 times 6 for 24. Root 3 units squared. Oops, forgot that in the last one. Is the area. I feel that I'm finding a pattern. If it's a triangle or a hexagon or a square, I think we're going to have 30, 60, 90, 45, 45, 90. But if it's a pentagon, it never is. We already had our pentagon central angle. It was 36 degrees. So I already know I'm going to have to use trig here. So half apothem times perimeter. I know the apothem is 4. So at least there's that. I don't have to find both. To find the perimeter, I'm going to do the number of sides times the side length. So 5 times, I don't know yet. So to find that half side, I'm going to find the side and then double it. The side that I want is opposite. and I have the adjacent, so we're going to use tangent. And like I said before, guys, if you know one and need the other, you're going to just use tangent. So tangent of our angle is, I don't know, over 4. And when your unknown is on top, you're just going to multiply both sides by 4. So we'll have 4 times the tangent of 36. So it's calculator time. 36 tangent times 4 is 2.9-ish. 91. Although, again, like I know I'm just going to, I got to double it. I got to double it. Times 2. I almost forgot. Is going to go right in here. So maybe if I don't chop any decimals off right now, like we can simplify this. Like here I have 20 in half. So really just 10 times whatever this is. So just 10 times this. And then I feel better because I'm rounding less. And so my approximate area is 58.12 units squared. And then last but not least, if I'm looking at this cute little octagon, I'm going to do half apothem times perimeter. Right now they've given me a side, so I can find perimeter, which is so nice that they've given me part of it. So we're going to do 6 times 8 for that. But I am going to have to find my apothem, and I have a guess that it's not going to be a special right triangle for this octagon here. So that means I'm going to have to use trig. And since I only have to find one thing, that probably means I'm going to have to use tangent. So thinking about my right triangle right here. First, I want to find that central angle by doing 360 divided by 8. Why can I not think? Oh boy. 360 divided by 8. Is 45. Oh yeah, this is the yucky one. I remember doing this last time now. And then divide that by 2 and it's like 22.5. Yeah, which we'll just go with 22.5. That's okay. I'm going to just use that, not 23. Round less. And so since I know my central angle is 22.5 and I know that the side is 6, so this little piece is 3, I have the opposite. And I want the adjacent, and opposite adjacent is tangent. So my guess was correct. To find our apothem, we're going to do tangent of our angle equals the opposite side, which is 3, over the adjacent side, which I'm trying to find. When our unknown is under, we're going to do a little swappy swap. And this is not the side that I'm finding, so I won't need to double it. And so it's calculator time. And we're going to do 3 divided by 22.5 tangent equals, to get this approximate apothem. Although, again, like maybe I'm going to save it so that I can just multiply by that. Like the perimeter is just 48, and then half of that will be 24 times the apothem, so times 24 gives me my approximate area of 173.82 units squared. Oh, I know it's a lot, but you can do it. You guys are the best.